Number patterns, final exam test. Now this one, the third test, is a breakdown and content that is similar to what you can expect in your final exam. So this is a structured test out of 50 marks with the content as examinable in matric exams, with also some grade 10 and 11 knowledge and content that you must be able to apply in here. Alright, so the first question says, prove that a plus ar plus ar squared plus ar n minus 1. So prove that the series as given here is equal to a r n minus 1 over r minus 1. Right, now this is a formal proof that you must be able to do. If you don't know how this proof looks like, you can really just go back to the proof video, the second video in this chapter, and just go look at that, because I did all of the proofs there, so I'm not going to do it here. This is for 5 marks. The second question is calculate the 11th term of the sequence 3, 3 root 3, 9, etc. Right, calculate the 11th term of the sequence. Now this looks like it's not a constant number added. It looks like it might be a multiplication problem. Let's quickly see. 3 root 3, it might be a geometric pattern. 3 root 3 over 3 gives me root 3, and 9 over 3 root 3, I'm just going to grab my calculator. 9 over 3 root 3 gives me root 3 also. Right, so to find the 11th term, I've got a geometric pattern with a equal to 3 and my r, my constant ratio here is root 3. That means my general term is 3 times r to the power of n minus 1, like that. And then the 11th term of this sequence will be 3 times root 3, 11 minus 1. So this is 10. Alright, so 3 times root 3. I'm just going to put root 3 inside brackets to be safe, to the power of 10, or you can put 11 minus 1 if you want, and that is 729. Alright, then question 2, this is for 3 marks. Then question 3.1, question 3 says given that the sum of n from 1 to 5 log x to the power of n, given this, then question 3.1 says write down the first 3 terms of the sequence. So that would be log x to the power of 1, like that. Then log x to the power of 2, which from my log rules I know is 2 log x. Then log x to the power of 3, and from my log rules I know this is 3 log x, like that. And then it says state whether the series is arithmetic or geometric and give a reason for your answer. Right. Now I would say this is plus log x plus log x plus log x. This is an arithmetic series. The reason being my constant difference is log x. Right, I've got a first term log x, and then my constant difference is log x. Right, this counts 1 mark and 2 marks for this question. Right, then question 4 says the first 3 terms of an arithmetic series are minus 4 over 5, minus 3 over 5, minus 2 over 5. The first 3 terms of an arithmetic series is this. Find an algebraic expression for the sum of the first n terms and write the answer in its simplest form. Right, now this is an arithmetic series with a minus 4 over 5 and my d value is minus 3 over 5 minus 4 over 5, and this is 1 over 5, positive 1 over 5. If you're unsure, use your calculator. So then, if I want an algebraic expression for the first, the sum of the first n terms in its simplest form, I can simply just use this formula. Sn is equal to n over 2 times 2a plus n minus 1d, like that, with n over 2, with a is minus 4 over 5, and n minus 1, my d value is 1 over 5, like that, and then I must just simplify this a little bit. Okay, so this is n over 2 times negative 8 over 5 plus 1 over 5n minus 1 over 5, like that. And then this is n over 2, 1 over 5n minus 9 over 5, which is 1 and 4 over 5. Right, and then I think you can leave it like that. If you want to go one step further, simplest form, you might just take this guy and multiply it in. To decide whether I'm going to do that, I'm just going to look at the amount of marks given. It's 4 marks. I'd say this is fine. And if it was 6 marks, I'd go to multiply this one in also. Then you have, just to show you, then you have 1 over 10 n squared minus, this is 9n, so 9 over 10 n, like that. Okay, so that is then in its simplest form, like that. Right, so question 5. Right, question 5 is 5 marks. It says calculate the value of m if m is equal to the sum of k from 3 to 11, 5 to the power of k minus 4. Right, now since it's starting at 3, I just start with the first term. Here is going to be 1 over 5. It's 5 to the power of negative 1. My second term is then where k is 4, and that is then 5 to the power of 0, which is 1. And then my third term is 5 to the power of 5 minus 4. It's 3, 4, 5, right? So 5 minus 4 is 5, and then I can see that this is a geometric pattern with my first value 1 over 5 in standard form, and then a constant ratio that I multiply with 5. So 1 over 5 times 5 is 1 times 5 is 5, etc. And the amount of terms that I have here is 11 minus 3 plus 1. You always take that minus that, which is 8, plus 1 is 9. So I've got 9 terms with this pattern. Now I know the sum to n of a geometric pattern is a r to the power of n minus 1 over r minus 1. This is what we proved there in number 1. And then my a value is 1 over 5. My r value is 5. My n value that I must work with here is 9. The sum of 9 terms in this pattern will be to the power of 9 minus 1. This is really simply, and then 5 minus 1. This is really simply knowing which formula to use, substituting calculator and answer. And this is 5 marks. This will count 3 marks for finding the correct formula, substituting, and your answer. And then the other 2 marks will probably be allocated to find the values of a and r, which you must substitute in there. So that's the 5 marks. Right, and then I can just substitute this into my calculator. So I've got 1 over 5. 5 to the power of 9 minus 1. Just make sure you don't minus the 1 there at the 9, but here underneath. 5 to the power of 9 minus 1 is 5 to the power of 8, where 5 to the power of 9 minus 1 is 5 times 5 times 5 times 5, 9 times, and then that answer you just subtract 1 from. And then I'm just going to put this over. So make sure you have it like this. And then 5 minus 1. And that gives me 97656.2. Like that. Right, so that is the value of m, actually, for 9 terms. The value of m is the sum of 9 terms with my a and r value, like that. Alright, so question 6 counts 8 marks. I'm just going to start anew because I feel this might be a little bit of a small space for 8 marks. So question 6 is 8 marks. It says in an arithmetic series, the fourth term is minus 2 and the 8th term is minus 18. Find the number of terms in the series if its sum is minus 144. Right, so term 4 in an arithmetic series, I've got my general term is a plus n minus 1d, like that. So my fourth term will be a plus 4 minus 1, so a plus 3d. And they say that that is minus 2. And my 8th term will be a plus 8 minus 1, which is 7d, and they say that that is minus 18. Now I must go do simultaneous equations with this and substitute it in there to find the n. Right, so first let's just find a and d, and if you get lost with the process easily, go find a and d here. A plus 3d is minus 2 and a plus 7d is minus 18. I'm going to find a and d here, and then I'm going to work with the fact that n over 2 times 2a plus n minus 1d is equal to minus 144. If I found a and d, I must go find n here. Right, so I just write down the whole process in the beginning. Okay, so from this, I have that a is minus 3d minus 2. That I'm going to substitute in there. Minus 3d minus 2 plus 7d is then minus 18. So 7d minus 3d is 4d is then equal to minus 18 plus 2, which is minus 16. And that means d is equal to minus 4. And then I can go and find my a value if I substitute this back in there. A is equal to minus 3 times minus 4 minus 2. This is 12 minus 2. So A is 10. And feel more than welcome to use your calculator yet again if you're unsure of quick calculations in your head. So I've got the value of A and D. Now I can substitute that in there. So A is 10. Plus n minus 1 and d is negative 4 is minus 144. Right, so let's go and calculate this. I'm just going to multiply throughout with 2 to get rid of this 2 there. So I've got n 20 plus negative 4n. Let's just do negative 4n plus 4 like that. I really just multiplied this out. I didn't change anything here. And here I just, because this is one term with the brackets stays the same, just that I multiply with 2. And this I multiply with 2 then. And then I can multiply the n in maybe. So I've got 20n minus 4n squared. Plus 4n is equal to minus 288. And then I've got negative 4n squared plus 4n, and I'm going to bring this over, plus 308. Let me just check. 288 plus 20 is 308 is equal to 0. So, oh, that's not a, whoops, that's an n number. 20 plus 4n is 24n. And then that just plus 288. Right? And then can 288 be divided by 4? Yes, it's 72. Okay, so I'm just going to divide throughout with a negative 4 to get rid of this. So if I divide this by negative 4, I just get n squared. If I divide 24 with negative 4, I get negative 6. And if I divide 288 with negative 4, I get negative 72. Like that. Okay, now I know 8 times 9 is 72, or 36 times 2. I just want to factorize this quickly. 72 times 1, 2 times 36 is not going to work. 72 divided by 3 is 24, which is not going to work. 72 divided by 4 is 18. 72 divided by 5 gone 6. Let's quickly divide it by 6. 12, 6. Yes, that's going to work. And then 7 is not 8, 9. So these the factors. So I'm going to divide 12 and 6. 12 and 6, negative n is negative 12 or plus 6. Okay, all right. So n is 12 or n is minus 6. Right. What did they ask? They asked in an arithmetic series, the fourth term is -2 and the eighth term is minus 18. Find the number of terms in the series if its sum is -144. Now, obviously, I'm not going to add minus 6 terms. I'm going to add 12 terms to get that. So then I'm just going to say this is not applicable because it's number of terms, and then I can say 12 terms will add up to -144, or you can say n must be 12, or just write some sort of conclusion there. All right, so that's question 6. Question 7. Question 7 is for 5 marks, and it says, given the geometric series 6 plus p, it's for 5 marks, 6 plus p plus 3 and 3 over 8 plus, like that. They state it's a geometric series. Calculate the values of r and p if it is given also that the values of r and p is the things that I must calculate. If it is given that the sum of the series to infinity is 3 and 3 over 7. All right. Okay. So to find the value of p, there's a formula that you can use, either plus or minus 3 over 8 times 6. So the square root of 3 and 3 over 8 times 6 is 9 over 2 geometric. But that does not make sense now. 3 and 3 over 8. Let's quickly see. Times 6, square root of that is 9 over 2, yes. Oh, that's that. Okay, yeah, so that's the value of p for question 7. And then they also want the value of r. Now, technically, I can just take r is then p over the first term, and I've got p can be either plus 9 over 2 over 6, 9 over 2 divided by 6, it's 3 over 4. So r can be either that, or r can be negative p over 6, which is negative 9 over 2 divided by 6, or over 6, and that should be negative 3 over 4 then. Or you can really just actually write it like that, plus or minus 3 over 4. But now they say, so I've got two possible r values here, and now they say they give me the this. So I think I must just go and establish whether r is positive or negative by using this. So the sum to infinity is equal to a over 1 minus r. And let's quickly see if I have positive 3 over 4. So positive, if r is positive 3 over 4, then I have my a value, which is 6, over 1 minus 3 over 4, 6 over 1 minus 3 over 4, and that gives me 24. And if r is negative, I have 6 over 1 plus 3 over 4, because it's then negative 3 over 4. And then if I go and change that to a plus, what am I doing? Plus, then it gives me 24 over 7. 24 over 7, which is actually 21 is 3 divided by 21 divided by 7 is 3, and then there's 3 over 7 left. So then can you see from this test that my r value must definitely then be negative 3 over 4. Alright, so this test here I just went and used to determine whether my r value is positive or negative. Right, this is for 5 marks. Then question 8. There's 9 questions, so we're almost done with this. Question 8 says a quadratic pattern has a second term of 7, a third term of 19, term 1, term 2, 3, 4, 5. Okay. A quadratic pattern has a second term of 7, a third term of 19, and a fifth term of 61. Right. And then they say calculate the second difference of the quadratic pattern, and hence or otherwise calculate the first term. Right. Now I know that if I take 7, let's call this a, which is the first term, and let's call this fourth term there b. Right? It always helps if you write down, then the person who marks your work can see what you were doing there. So I can say that 7 minus a is this first difference. 19 minus 7 is 12. B minus 19 is this. And 61 minus b is that. Right? And then I know that my second difference, 12 minus 7 minus a, and be careful not to leave out the brackets there, this and b minus 19 minus 12, and then this 61 minus b minus 19. All of these things should be the same. Alright, so that is something that I have here. So let's quickly see b minus 19 minus 12. Let me just simplify this a little bit. This is 12 minus 7, which is 5. 5 plus a, actually, and this is b minus b minus 19 minus 12 is minus 31, So b minus 31, 5 plus a, b minus 31, and then 61 minus 2b. There's minus b, so it's minus 2b, 61 plus 19, and that's 80. So 80 minus 2b. Right. Now I've got all of this should be the same. Now it's going to be better to work with these two because they both have b's in them. If I put 5 plus a is equal to b minus 31, it just doesn't really solve my problem. If I say b minus 31 is then equal to 80 minus 2b, here from there I can easily solve b. So b plus 2b, 3b is equal to 80 plus 31, which is 111. Okay, and then if I divide this by 3, I get 37. So b is 37. Right, now if b is 37, then I can just substitute it in there to say my second difference, my constant second difference in this quadratic pattern should be 37 minus 31, which is 6. Right? So my constant second difference is 6. That's for 8.1, they said. Calculate the second difference. And then for 8.2, they say hence or otherwise calculate the first term. So 5 plus a should be 6, which is the constant second difference. That means a should be 1. Alright, so that is question 8. Understanding the workings of a quadratic pattern, this is not really difficult. 8.1 for 5 marks, which is mostly done there, and 8.2 for 2 marks. Alright, if you're not sure of how a quadratic pattern works, then this might be a bit of a challenge. But if you just know that the second differences is the same and you go network that out, it's not really a challenge to do this. Alright, then question 9, the last question here. Question 9 says a, b, root 3 are 3 consecutive terms of a geometric sequence. Determine the relationship between a and b. Determine the relationship between a and b. Now I know for a geometric series that root 3 over b should also be equal to b over a. And then if I cross multiply, I've got b squared is equal to a root 3. And then I can, I think I'd rather get a alone, so I'm just going to swap them. A root 3 is equal to b squared. Then that means a in terms of b is b squared over root 3. Right, you can get b alone also by just taking the square root, but then you have a square root over a square root, and that's just weird. Right, so that's the relationship between a and b for 2 marks. Then question 9.2 says, furthermore, a, b, and root 3 are also sides of a right-angled triangle. So a right-angled triangle, it's the sides of that, with a smaller than b smaller than root 3. Determine the relationship between a and b. Again, right, now if root 3 is the bigger one between a and b and root 3, the biggest one, that means that that is the hypotenuse, because the hypotenuse is always the biggest one. So then that's just why they say this, so that you can identify it. And then if I want to determine the relationship, I can say that a squared plus b squared should be equal to root 3 squared, which is 3. And that means that I'm also going to get in terms of a, because I've got that relationship in terms of with a alone. So I've got a squared is 3 minus b squared. I just solve for a. And then a is plus or minus root of 3 minus b squared, like that. Right. And then they say for question 9.3, then prove that a is equal to root 3 times root 5 minus 1 over 2. Okay, so I want to prove that. Now I actually want this in terms of b, because if I have now in terms of a, then I can say that b squared, because both of these expressions are equal to a, I can say b squared over root 3 is equal to plus or minus, I'm just going to work with the positive of that actually, is 3 minus b squared. And then simplify this from there, but now I'm working with b's, can you see, and I actually want to work with a's. So I'm going to go back a little bit. This question counts 6 marks. I'm going to leave this as it is. I'm just going to write this as b is equal to root. I'm just going to write this in terms of I root 3, this weird expression. And here I'm going to get b alone rather. So b squared is 3 minus a squared. So b is root of 3 minus a squared, like that. Right, and then I can say both of these expressions are equal to b. I can actually leave it b squared, because there's b squared equal to that, and then b squared is equal to this. So then if I put b squared equal to b squared, then I get a root 3 is equal to 3 minus a squared. 3 minus a squared, like that. Right. Now I want all of the a terms on one side, so I get a squared plus a root 3. This is now a squared thing, so I'm going to do it like this. A squared plus a root 3 minus 3 is equal to 0. It's a quadratic equation. Let me write this as root 3a. The reason for that being a quadratic equation with a equal to 1, b equal to root 3, and c equal to negative 3. And then I can find the value of a. There's two different a's here now. This a is the coefficient of a squared in a usual quadratic number. And this a is the a from the equation, which is a bit confusing, right? But a can be found by using minus b plus or minus root of b squared minus 4ac over 2a, this quadratic formula. All right, and then this is minus root 3 plus or minus root of 3 minus 4 times a, which is 1, times c, which is minus 3, over 2 times a, which is 1, 2. Right, and this is then 3 plus 12, which is 15. So root 15. This is then minus root 3 plus or minus root 15. And 15, you can go right as plus or minus. You can go right as 3 times 5, which is then root 3 times root 5 over 2. Okay, and then I can take out the root 3 as a common factor. My space is a bit limited here now. Maybe I can fit it in here. That's very skew. Still very skew. Okay. Maybe I can fit it in here. So then I've got, I'm going to take this term first because I see that's where that's going. Let me swap them around. So I've got plus or minus root 3 times root 5 minus root 3. I just swapped these two terms because I see that's where this is going with the root 5 minus 1. If I take that out over 2, and that is then equal plus or minus root 3 times root 5 minus 1, which can actually, if I take out a plus 3, that's minus 1, and if I take out minus 3, that's actually plus 1. So if I take out plus root 3, then that's minus 1. Or if I take out minus root 3, then it gives me root 5 plus 1 over 2. So it gives me this or that. But they say that prove that A should be equal to this, so A is then equal to that, or that, but to be very technically correct, but that then. Alright, so that is the breakdown and content as per the final exam, typical things that you can expect of number patterns.